Good morning students, welcome to online class DEO Nalgonda. After complete the first section, next we continue the second section. There is electrical conductivity, how the electricity is passed through the acid solutions and basic solutions. So there is the activity is there. First we have to prepare the 4 solutions: glucose, alcohol, hydrochloric acid and sulphuric acid solutions we have to prepare. How we prepare the solutions means by adding with the water. Glucose to the water, we have to mix it to the water, it gives the glucose solution. Alcohol to the water, it mix it together, it gives the alcohol solution. That like hydrochloric acid, sulphuric acid solutions we have to prepare. So we have to set up the electrolytic cell. How we have to separate? Take a beaker. In that beaker, this is the rubber. We have to fix it the rods. This is iron rods. It is also conductors. This iron rods connected to the wires. This wires connected to battery, negative pole of battery and positive pole of battery. At the middle you have to keep one bulb and switch. This bulb is to identify passing of electricity through the solutions. Okay. So first in this beaker you have to take the dilute HCl solution. So for example here no solution is there, only empty is there, means this is the electrical circuit, 2 iron rods, it is the rubber, it is fixed in the beaker. So next we connected 2 wires, battery, at the middle you have to keep the switch and bulb. Okay. So it is rubber is generally insulator and rubber is not conductor. So here it is not complete the circuit without any solution in the beaker. Without any solution in the beaker, it is 2 iron rods separately is there. This middle rubber is there. Rubber is insulator. Rubber is not a conductor, so that's why it will not allows the current. So what about the, if you place the, in this beaker if you place the solutions, for example if you place dilute HCl solution, okay. So what is happened in the dilute HCl solution? The electric current is the battery is on. The electricity is passed through the wires and it is reaches the iron rods, and this iron rods and middle what is there here? Dilute HCl is there. Okay. So dilute HCl, next we observe what is happened, switch is on, if it is switch is on, the bulb is glow. So why? Because the dilute HCl is it is the conductor, it is allows the current, so that's why the bulb will glow. So same, repeat the experiment with the other substances also like glucose, alcohol and sulphuric acid. So we conclude that in the which case the bulb will glow means glucose and alcohol case the bulb is not glow, and hydrochloric acid and sulphuric acid solutions in the case the bulb will glow. So why? Because the acid solutions can allow the current, they are the conductors. Okay. So generally the conductivity is responsible for movement of ion from one place to another place. Okay. In the HCl ions are separated as a H plus and Cl minus ions. Okay. The plus ions are moved towards to negative electrode and minus ions are moved towards to positive electrode. So that's like the movement of ions is occurred in the dilute HCl. So that movement of ions carries the electricity, so from one place to this rod to this rod. That's why that bulb will glow. But in the case of glucose, okay, C6H12O6, okay, this molecule will not dissociated into ions. So that's why that ions formation is not occurred in the glucose and alcohol. So that's why they do not allow the current. So in the exam, in the board exam, so we have to they must and should they ask about the draw the electrical setup, electrical conductivity of the acids and bases they are asking. So that's why we have to know this how the diagram of this electrical conductivity. Okay. So this for example if you take fluid substances, glucose and alcohol solutions are not allows the current, they are not conductors, then do not allows the electricity, and hydrochloric acid and sulphuric acid and basic substances also allows the current, they do not they are conductors. Okay. So this is electrical conductivity. Okay. And next, if suppose you see NaCl reacts with sulphuric acid, it gives HCl and Na2SO4, sodium sulphate. Okay, first in one test tube you take the sodium chloride solution, NaCl solution. Okay, and to this NaCl solution we had to add the concentrated sulphuric acid. Okay, concentrated sulphuric acid. So the reaction between NaCl and sulphuric acid, here you keep one hole rubber cork this one hole rubber cork you keep one capillary tube. Okay, through this capillary tube the HCl is released as a gas, the Na2SO4 is forms the solution, the HCl is released as a gas, the pure HCl gas is released. Okay, the pure HCl gas is released. So here we have to take two litmus papers, dry blue litmus paper wet blue litmus paper. Okay, dry blue litmus paper, wet blue litmus paper. So in this test tube, the reaction between the NaCl and sulphuric acid, the NaCl and sulphuric acid is reacts together, it releases the gas is HCl gas. Okay, at the release at this top of at the open of this capillary tube, first you place dry blue litmus paper. Okay, dry blue litmus paper. In second case you keep wet blue litmus paper. In these two cases, first you keep dry blue litmus paper, in the second you keep wet blue litmus paper. In these two cases, in which case the blue litmus paper change into red? Can anyone guess? In dry blue litmus paper doesn't change into color, wet blue litmus paper is changed into red. Okay, why? Because dry blue litmus paper, two are blue litmus papers only, but it is dry and but this one is wet. Okay, what is the difference of these two? Here absence of water, here presence of water. So the HCl, okay, the HCl in presence of water, this HCl is released the ions H plus. In presence of water only it is formed as a H3O plus. So the HCl in the presence of water only it is existable, it shows its acidic nature, but in the absence of water the bare H plus ions are not existable. The bare H plus ions are not shows its acidic nature, that's why the dry blue litmus paper is doesn't change into red, only the wet blue litmus paper is changed into red. Why? Because the wet blue litmus paper is contains a water molecule, that water molecule, the HCl gas in presence of water molecule only it shows its acidic nature. Okay, so that is the activity we observed, the nature of the HCl. The HCl in presence of water only it shows its acidic nature. Why? Because the HCl contains H plus ions it is not stable in bare ions, and only single HCl is not stable. In presence of water only it is exist as a H3O plus ions. Okay, so that's like here activity is there, sodium chloride solution added to the concentrated sulphuric acid. These two reactions together release the HCl gas. This HCl gas is tested by the dry blue litmus paper, wet blue litmus paper. Dry blue litmus paper is doesn't change into red, but wet blue litmus paper is changed into red. Why? Because dry blue litmus paper, the HCl, the pure HCl on the dry blue litmus paper is it not shows its acidic nature on the dry blue litmus paper. In wet blue litmus paper, the HCl gas in presence of wet, okay, in presence of wet only it shows its acidic nature. Okay, so this is the nature of the HCl in presence of water. Okay, the HCl is separated as a H plus and Cl minus, but in the presence of water only the H plus in presence of water it forms H3O plus. Okay, H plus in presence of water it gives H3O plus. 2 hydrogens, here 1. So total 3 hydrogens, 1, 1. Here no charge, but this H plus is carries the positive charge. So the total ionic molecule is H3O plus. It is the existable ion. It is existable H plus ion in presence of water. Okay. And next, okay, next you see more. In one test tube, acetic acid CH3COOH. In one test tube, HCl. Okay. So in one test tube I am taking acetic acid, that is CH3COOH. In second test tube I am taking HCl, hydrochloric acid. So two are acid substances only, but what is the difference of these acid substances means it is slowly released into the ions on dissolving in water. It is fastly release the H plus ions on dissolving in water. So which is slowly release H plus ions on dissolving in water, that is considered as a weak acid, and which is fastly release H plus ions on dissolving in water, that is the strong acid. Okay. So this like acids only, but the difference of strength, they are the two types, strong acids and weak acids. We can measure that strength of acids by using the pH scale. Okay. By using the pH scale we can measure the strength of acids and bases. Okay. The pH is for measuring the strength of acids and bases. So there is a scale from 0 to 14 number at between 7, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 14. So it is the pH scale. Okay, at the 7, the pH value at the 7, it is considered as a neutral substances. The less than 7, it is considered as a acid substances, and greater than 7, it considered as a basic substances. Okay. Less than 7, it is considered as acidic substances, and greater than 7, it is considered as a basic substances. On moving of 7 to 0, the acidic nature increases. Okay, on moving of 0 to 14, the basic nature increases. Okay. On moving of 7 to 0, the acidic nature increases. On moving of 7 to 14, the basic nature is increases. Okay. So generally the pH values 7 to 3 middle, they are the weak acid, and 0 to 3 between, they are the strong acid, and 7 to 11, they are the weak base, and 11 to 14, they are the strong base. Okay. So this like the acidic nature and basic nature strength we can observe by using the pH scale. Okay. The pH values are from 7 to 0, they are acidic nature. At the 7, they are the neutral, neither acidic nor base. Okay. They are the neutral substances. For example, salts. Salt also, which salt is formed with strong acid and strong base only, it is 7. And above 7 is, they are the basic nature. Okay. So for example, your SEMA, distilled water, it is a neutral substances. The pH value is 7. Okay, there is in the textbook there is a scale, some examples also is given. Okay, suppose baking soda, it has a mild basic in nature, so the basic value is 7.8 something is there. Okay, and washing soda, that value is 12.8. So that's like by using, if suppose pH values, suppose A, B and C and D. So this 4 A, B, C, D 4 substances is there. These 4 substances pH values are 3, 14, 7, 2. Okay. So if suppose this like in the textbook there is a, in textbook this lesson after backside, this backside questions is there. It may ask the, in the board exams the questions it will ask like if suppose I am giving the ABCD solution, the pH values are 3, 14, 7, 2. So what are the nature of that A, B, C, D and values? What are the nature of that solutions? So by using pH value we can say what are the substances. Okay. So here 3 is A means that is the weak acid, and 14 is A means that is the strong base. Okay. At the 7 pH value is at the 7 the pH value is what? Neutral. Okay. 2 is A means below 3. Okay. Below 7 and below 3 is A means that is also considered as a strong acid. Okay. So this like we can express the strength of acid and base by using the pH values. Okay. Okay, next these pH values are very important in our daily life. Okay, in our bodies also contains some fluids, that fluids also has a certain pH values, blood, okay, urine and the gastric fluids is there, they has some pH values. If any disturbances on the pH values, some our body is disturbed by their regular activities. So here how the importance of the pH value is affected on our daily life. Okay, for example, suppose you see rainwater, generally the rainwater pH value is 5.6. Okay, generally the rainwater pH value is 5.6. If this pH value is less than 5.6, if rainwater is less than, the pH value is become less than 5.6, what happened? That rainwater is become acidic nature. So that rainwater is become into acid rains. That acid rains will damages the buildings and the trees, and our skin is also damages by affected the acid rains. Okay, so how they are forms the acid rains ante the mixing of sulfur dioxide gas. Okay, in the environment, if sulfur dioxide or sulfur trioxide gases are highly released, if suppose sulfur dioxide and sulfur trioxide gases are released into the atmosphere, while raining, the rainwater is mixed with this sulfur dioxide and sulfur trioxide, it forms the sulphuric acid and sulphurous acid. That sulphuric acid and sulphuric acid increases the acidic value of the rainwater. So that rainwater is become acid rains. So that acid rains are affected the monuments, that is buildings and the trees. The trees is also green color plant trees are damages and turns into the yellowish color. So that pigments is lost. So that's like the trees are some disturbances is along the regular photosynthesis reactions. Okay, in our bodies also when it is get acid rains, some allergies is occur on our skin. So that's like it is affected the pH value. Normal rainwater pH value is 5.6. If less than 5.6 means the acidic nature increases in the rainwater. That rainwater is that rain is considered as a acid rains. That acid rains are damages the buildings. Acid rain pH value is less than 5.6. Okay. Suppose next to tooth decay. Okay, tooth decay. So tooth decay is also occurred by the high excess acid is released in our mouth. Generally in our mouth, the gastric fluids in our mouth, the fluid contains 5.5 pH value. So if this 5.5 pH value is less than, and if it is decreases by we are eating food, that food is storing into our mouth, so it is slowly releases the acidic nature, that acids is released into our mouth. That acid released into our mouth means acidic nature increases in the mouth. That acidic nature increases, the pH values fall down into the less than 5.5. So that acidic is corroded to the tooth enamel. Okay, the tooth enamel is formed by calcium phosphate. That calcium phosphate is affected the acidic nature released in our mouth. So thus like the tooth decay is occurred if acidic substances or acidic increases in the mouth. Okay, that is also it is affected tooth decay. Okay. And when we are eating the food, it is digested in our mouth to certain extent, and next it is entering into the intestines. The intestines is release the some gas, HCl gas. That HCl gas is used to digest the food. So if generally we are eating regular timings and proper only equal quantity of food we are eating daily, so we can save our body is habituate the certain amount of HCl to releasing the digest the food. If suppose one day or if any time we are eating excess food, if we are eating high pungent food, okay, high spicy food we are eating, so that spicy food is digested by more excess of acid. So it is really more excess of acid means the acidic is more increases in our body, that leads to acidity. So that acidity we feel as a pain and irritation in our body. To relieve from that pain and irritation, we have to use the antacids. Generally we are immediately relief from that irritation, we have to using the antacids. So what are the antacids we are using generally means milk of magnesia. So the milk of magnesia, that is magnesium hydroxide MgOH taken twice. So the magnesium hydroxide MgOH taken twice, it is the basic substance now. So excess of acid released in the body, so to nullify and to neutralizing that excess of acid, we have to using the magnesium hydroxide basic substance. Okay, so this like in our daily life we are using the pH values. Okay, rainwater pH value is 5.6, if less than 5.6 is become acid rains. Okay, in our mouth generally the fluids is released the 5.5 pH value. So if more acids are released in our mouth, it is caused to damages the tooth enamel, that leads to tooth decay. Okay, and excess of fluids is released, excess of HCl gas is released in our body for unnecessary habit of our food. So that is leads to acidity. To relieve from the acidity, we have to use the antacids. Okay, so that is the milk of magnesia. So not only this one, in the soil also. Okay, soil also in the different places different types of soils is there. We can test the soil by using how we can test the acidic nature of the soil and basic nature of the soil means first you take the soil in one test tube. Okay, mix it with water. Okay, mix it with water and keep it aside for overnight. Okay, then filtrate the filtrate. Okay, take out the filtrate which contains the minute particles of that particular soil. So next you tested the pH value of that soil. We can know that soil has a how much of pH value. Okay, so that's like we can observe the pH value of the soil. So that pH value of the soil is if it is acidic nature, we have to cultivate the crops by adding basic fertilizers. If that soil has a basic nature, we have to cultivate the crops by adding acidic fertilizers. So that's like this pH value is very important in our daily life to our daily life activities are without any disturbances is occurred. it is very important in our daily life. Okay. Suppose for example, the mixing of acid and base, it gives salt and water. Okay, what is this reaction? Neutralization reaction. So this neutralization reaction, in last class I said acid reacts with base, it gives the salt and water. So acids are two types, strong acid, weak acid. Bases also two types, strong acid, strong base, weak base. The substances are reacts together. What are the types of salts is formed and what is common? Okay, for example, strong acid. Strong acid reacts with strong base. Okay, it gives neutral salt. Okay, strong acid reacts with the strong base, it gives neutral salt. If suppose strong acid, weak base. Okay, strong acid, weak base. So here which nature is dominate? Acid nature is dominant. So the salt is which nature is get? Acid nature is get. So we can get what is the salt of nature? Acidic salt. So we can get acidic salt and water is common. Okay. If suppose weak acid, strong base. Okay, weak acid, strong base. So weak acid, strong base means in this case acid and basic, which is dominating means basic nature is dominating. So our producing salt has a basic in nature. So the basic salt is formed. Okay, basic salt plus water. Okay, so this like our salts is also different. Neutral salts, acidic salts, basic salts and water. Suppose weak acid, weak base, it gives a neutral salt. Okay, and water. Weak acid and weak base. Weak acid and weak base also depends on the weakness. Okay, if acid is more weak than weak base, so it is gives little acidic nature. If base is more weak than weak acid, it gives a little basic in nature. So that is depends on the acid and basic combination reaction, it gives the salts. Salts is also different types of salts we can get. Strong acid, strong base gives the salt and water, neutral salt and water. Strong acid, weak base, it gives acidic salts. Weak acid, strong base, it gives basic salts. Weak acid and weak base, it gives the neutral salts only, but depends on the weakness it producing the dominating that salt is get the acidic nature or basic nature. So this like in this section what I said, first electrical conductivity of solution, acidic solutions and basic solutions. Okay, generally acids, bases are can elevate the current, they are the good conductors of electricity. Okay, but glucose and alcohols, you are saying glucose and alcohols are not good conductors. Why? Because they are the neutral substances, they do not allow the current. Okay, the electrical conductivity diagram is important. And next to HCl gas, the HCl gas, dry HCl gas is not shows its acidic nature on the blue litmus paper, but wet blue litmus paper the HCl gas shows its acidic nature. Okay, that is the HCl gas we are having activity. And next the strength of acid based on the strength of acid or base. Okay, based on the strength of acid and base, there is a scale is there, that is a pH scale. Okay, this pH scale, the values from 0 to 14. Okay, at the 7 there is a neutralic substances, and less than 7 they are the pH value is acidic in nature, and greater than 7 they are the pH value is basic in nature. Okay, and these pH values are very important in our daily life. How they are important means rainwater, it becomes into acid rains, tooth decay is occurred by excess of acid released in the mouth, and gastric fluids, if excess of HCl gas is released in our body for digesting. So excess is released, it gives acidity. To acidity we relieve from adding antacids. The antacids are magnesium hydroxide, and the combination of acid and base, it gives the salt and water neutralization reaction. But depends on the strength of acid and base, it gives the different types of salts. They are the acidic salts, basic salts and neutral salts. Okay, next we will meet into next section. Thank you. Good morning students, welcome to online class DEO Nalgonda. In this acid bases and salts lesson, that is third section, the first two sections is completed. First section, indicators and reactions of acids and bases with metals and carbonates and bicarbonates reactions, neutralization reaction. In the second section, completed electrical conductivity, HCl gas, dry HCl gas is affected on the dry blue litmus paper, wet blue litmus paper, and the pH value, the strength of acid and bases, the pH value, how it is importance in our daily life. Okay, and next salts are different types of salts we learn in these first two sections. Okay, it is the third section. There are the salts is there, how we prepare these salts and what are the uses of these salts we are learning in this section. So, what is NaCl? NaCl is the common salt. Okay, generally our using table salt. This NaCl, it is used that it is the main important raw material in the sodium hydroxide, baking soda, NaHCO3 and Na2CO3, washing soda and CaOCl2, bleaching powder. So, in this compounds we using this NaCl salt. Okay, so the NaOH from the common salt. Okay. So, how we can prepare the sodium hydroxide in the common salt means the sodium chloride solution on electrolysis, it gives the sodium hydroxide and hydrogen gas and chlorine gas. Hydrogen gas is released at the cathode and chlorine gas is released at the anode. So, these three substances are released on the electrolysis of sodium chloride. This sodium chloride solution we also called as a brine solution. This brine solution on electrolysis, three products are produced: sodium hydroxide, hydrogen at cathode and chlorine gas is anode. Electrolysis, thus that why it is two electrodes is a cathode and anode. Okay. So, the hydrogen gas is generally we used as a fuels and a margarine. Margarine means like dalda, that margarine we called it as a dalda, vanaspati. And ammonia preparation, N2 plus H2 gives ammonia NaH3. So, ammonia preparations and this ammonia is used as a fertilizers. And chlorine is used as a water treatment and purifying the water, and disinfectant, it is used as a disinfectant, and chlorofluorocarbons, CFC preparation also we use this chlorine gas. And NaOH, sodium hydroxide. This sodium hydroxide are as degreasing of metals, soaps industries and detergent industries and paper industries and artificial fibers, we use this sodium hydroxide. Okay, and the mix sodium hydroxide and chlorine together, it is used to prepare the bleaching powder, that is the CaOCl2, and hydrogen and chlorine gas, this two is reacted together, it gives the HCl, hydrochloric acid. That hydrochloric acid we use the ammonium chloride, NH4Cl, means NH3 plus HCl. Okay, NH3 plus HCl, it gives ammonium chloride, and it is this hydrogen and chlorine combinations react together, it gives in the medicines and cosmetics. So, we use this hydrogen and chlorine combination. Okay, and next we are going to bleaching powder. Okay, bleaching powder, we prepare the electrolysis of NaCl solution, it gives a chlorine gas. That chlorine gas is passed through the dry slaked lime. Okay, what is slaked lime ante? Calcium hydroxide. The calcium hydroxide is reacted with the chlorine gas, it gives the calcium oxychloride, CaOCl2. This CaOCl2 is the bleaching powder, commonly called bleaching powder. Chemical name is calcium oxychloride. This calcium oxychloride is we call as a bleaching powder, and water molecule is released. So, this bleaching powder we use to bleach the substances, bleaching cotton and linen in textile industries, and wood pulp, paper to bleaching in paper industries, and in the laundry to clean the clothes we use the bleaching powder, and oxidizing agent in the laboratories, and oxidizing agent is used. Why? Because the CaOCl2 is used as a oxidizing agent ante the CaOCl2 has a oxygen, that oxygen is used to give to other substances get oxidized. Okay, ఏదైనా substance అనేది oxidation చెందాలి అన్నప్పుడు it required oxygen. So, this bleaching powder has the CaOCl2 has a oxygen to give the oxygen, some other substances get oxidized. So, that's why this is called as a oxidizing agent. So, this calcium oxychloride is the oxidizing agent in the laboratories, and it is also used reagent in the preparation of chloroform CHCl3, and disinfecting water. Bleaching powder we used to drinking water purpose, to cleaning the to rid off from the germs. Okay, these are the uses of bleaching powder preparation. And next one is the baking soda. Okay, baking soda is sodium bicarbonate, NaHCO3. So how we prepare the NaHCO3 ante, the NaCl, sodium chloride, reacts with ammonia and water and carbon dioxide gas. Okay, these substances are reacts together, it gives ammonium chloride and sodium bicarbonate, NaHCO3. This baking soda is a mild non-corrosive base. Baking soda is a mild basic in nature. Okay, this baking soda produces the NaHCO3. That NaHCO3 is release the carbon dioxide gas to raises the dough into the cake and bread. Okay, to fluffy nature we can get by using this baking soda, adding the substances. Okay, why? Because the carbon dioxide gas is released it out and it become into smooth and spongy substances. Okay, this baking soda is also used as an antacid. Why? Because it has a mild basic nature. If acidity is increases, we a little baking soda we can get, it is neutralized that acidic nature. And it is also used as an antiseptic. Okay, if suppose honeybee, okay, honeybee if it is hit on our body, okay, we feel pain. Why we feel pain? Under that honeybees release the acid on the place. Okay, at that place if we rub with baking soda, that baking soda is mild basic. Honeybees release the acid, but baking soda is a mild basic. So two are get neutralized. That's why we are relieved from pain. So that is why it is also used as an antiseptic. And washing, this is about the baking soda. And next one is the washing soda. Okay, washing soda, NaCl. From NaCl we are preparing the baking soda NaCO3, and this NaCO3 on heating it gives the sodium carbonate Na2CO3. This Na2CO3 is called as a basic salt, and this salt has a basic in nature, little mild basic in nature. So this sodium carbonate reacts with water, it gives the sodium carbonate with 10H2O. This is the crystallized, this is the hydrated washing soda, and this washing soda is used in the glass industries, paper industries, soap industries, and it is also used as a borax, that is Na2B4O7 preparation also we use, borax powder preparation also we using this washing soda, and it is also used into cleaning purpose for domestic cleaning agent for domestic purpose, and to soften the water, hot water, soft water. In hardness, the removing of hardness of water, we are using this washing soda to rid off the hardness. Okay, and another one more substance is there in the acid basis lesson, that is the plaster of Paris. Okay, we call simply it is POP. Okay, so what is plaster of Paris? Simply we call it as a POP. Okay, this plaster of Paris obtained from the gypsum. Okay, what is gypsum? Ante calcium sulphate 2H2O. Okay, CaSO4 2H4. On careful heating of gypsum, calcium sulphate 2H2O, it gives calcium sulphate hemihydrate of H2O, CaSO4 of H2O. This is called as a plaster of Paris. Okay, and this is calcium sulphate hemihydrate. Hemi ante of hydrate. Okay, hemihydrate. So the plaster of Paris, POP, it is simply called, and it is obtained from the gypsum on careful heating of on careful heating of gypsum, it is gives the plaster of Paris, that is calcium sulphate hemihydrate. Okay, we use this calcium sulphate hemihydrate. Once it is contact with water, it becomes very hard material like a stone. Okay, so that's why in the doctors, if it is breaking, if fractured bones is there, means to set up the fractured bones, the doctors are using this plaster of Paris to cutting the to set up the bones. Okay, so and also we use this plaster of Paris to prepare the toys and some modules, some some we have to prepare this. We have to plaster of Paris is used this like in the preparation of toys and modules. Okay, this is about the plaster of Paris. Okay, next next one here you have observed carefully, the CaSO4 is reacts with the half H2O. So it is a combination of water, and here washing soda you see Na2CO3 with 10 H2O. What is that means? And the gypsum you see CaSO4 with 2 H2O. Okay, so they are the hydrated with water molecule. Okay, there are the have you seen the copper sulphate crystals? They are which in color? Blue in color. Okay, the copper sulphate copper sulphate crystals are blue in color. They are for CuSO4 5H2O. So on heating this copper sulphate blue color crystals, okay, these are the blue color crystals, copper sulphate 5H2O. On heating this blue color crystals, what happened? White color, the water is lost, water is evaporated. Okay, it forms copper sulphate. Water is evaporated, 5H2O molecules is evaporated. What is left? Copper sulphate molecules are left. So these are the white. Okay, so again if you add water, again that copper sulphate is recrystallized, again become into blue in color. Okay, first in our laboratory is there blue color crystals of copper sulphate. They are the hydrated copper sulphate 5H2O. On heating that copper sulphate crystal, blue color crystals, if you are taking in spoon on heating, on heat, what happened? That blue color crystals is turns into the white color paste. That white color paste formed by loss of water molecules. So what is left? Water molecules lost and 5H2O molecules is removed. What is left? Copper sulphate only is left. It is white color paste. So again next you add a little water to this paste. Again that water is again that copper sulphate is gain the water molecule. It become into crystallized. Okay, this is a once water molecule is lost, it becomes it lost the hydrate. It lost the it is dehydrate. Once it is gains the water molecule, it become into hydrated. Okay. So that is the recrystallization of substances. Okay. So the total overall the lesson, acids, bases and salts. Okay, what are the main important topics means indicators, olfactory indicators. Okay, phenolphthalein and methyl orange, how they are changed by acids and bases. Okay, and next to the reaction setup of the acid with metal. Okay, the hydrogen gas is released. Okay, how we and the carbonates, the carbon dioxide gas is released with acids and bases. And next to electrical conductivity, neutralization reaction. Okay, electrical conductivity, the diagram is important. And next to dry HCl gas, in presence of water only, the HCl shows its acidic nature. Okay, and next to different types of salts. Okay, the salts nature, acidic nature, basic nature depends on the combination of acid and base. Okay, next to pH values, the strength of acid and base, pH values. Okay, importance of pH values is important. Okay, and next to there are the some saltic substances, NaOH, NaCl, common salt, and washing soda, baking soda, and bleaching powder. Okay, and plaster of Paris. Okay, recrystallization. Okay, thank you.